There's a lot of different things you can do with particles once they exist also. You can instance geometry at each point location. You can render two-dimensional sprites that are camera facing. So if you don't want points, you want stars or whatever you want. There's several different things you can do. You can connect the points together and create geometry out of them. You can create tubes out of them. You can do all kinds of crazy geometry generation steps after that. Which is kind of what you did there. You did add, delete, and you connected them together.
So for this example here, what I did is I created an emitter which is just a line for my purpose, and the line I gave 735 points to match the approximate amount of samples in my audio stream. And onto this line I added a chop2 sub. Now what a chop2 sub does, it takes the chop channels from any kind of chop channels and maps every sample in your chop channel to a certain point attribute that you specify in the chop2 sub. So I'll just create another. You have a line with 735 points. I add a chop2 sub to it. Now the chop2 sub has a parameter called chop, and that parameter expects a chop. That's pretty straightforward. And now it wants me to say what channels from the chop map to what attribute. So my channels here are very nicely named channel 1 and channel 2. So I'm just going to type that in here. And my attribute scope is P for point positions.
Check that out though, that's cool.
And I get a warning here, because what it actually expects is the P expects 3 channels for X, Y, and Z point position, but I'm just giving it 2. So, I can just ignore the warning. It actually tells you what extra values attributes will have. But if you are annoyed from the warnings, I never like warnings in my networks, you can also specify which like P0 standing for the X point attribute, P1 for the Y point attribute. And what I just created is an XY scope. That's a typical, it's almost like a phase space thing, which actually, you can, you can extrude that. You can have tons of fun with that already.
Yeah. Facet. Compute normals.
Turn it around. Or
compute normals.
Compute lit. Oh, look at that. Nice. Huh? Yeah, and you might end up just looking at it like that. Anyhow, what you also can do is, it's not only the point attributes or the point position that you can change, you can also change the point normals. And as we said before, the particles are emitted depending on their emitter's normal value, emitter point's normal value. So if I actually...
You should just bypass the chop 2 to show what it does if you don't do that, yeah.
Right, so if nothing happens.
Because a line doesn't have any normals associated with the points,
right.
So you're not going to see anything. Because the points don't have any velocity. They just come into existence and they stay exactly where they started. So you have to have a normal value in order to get it to move.
And by adding the normals to the line and then attaching a particle system, I get this behavior here. I guess I don't have any forces set in here, it's just the default particle system, but the same thing that I showed you before. I have a very high birth rate and a low life expectancy.
But you were able to add an attribute to an object that didn't necessarily have it just by typing it in.
You can do that. There's an attribute create, and you can have color attributes associated with points. There's it's basically freeform. You can assign totally new attributes. Yeah.
When looking at this, at the initial render output here, what you will see is that it's all lines. Do you mind if I turn the background flag? Sorry. There. This is actually lines and not particles, not points. And the question is how did I get to this point? It's after the particle, I used an add sub to delete all geometry and basically just keep the point information, essentially. So the add sub has this parameter down here that says delete geometry but keep the points. The next thing I did is I deleted a pretty high number, like almost 70% of the 80% of the points here. Probably did that because I just liked it better this way. Then I sorted the points in X. I wonder what it would look like. This is sorting the points in Y or in Z or randomly. So I guess X makes the most sense. And then I used the add sub again to select all points and convert them into one polygon. So there's on the second page of the add sub, you can take the input geometry, specify points, and here I specified all points by putting a star in there, and then said create me a closed polygon. And with these, what the closed attribute does is it gives me these connecting lines, basically. Like it tries to build a closed thing. So, well, the last thing was, I don't know, I actually put texture coordinates on it. It's probably unnecessary. Render this. So this is your rendered output. Now this looks a little bit different from the actual output, and that's because I added a feedback in between. I find myself using feedback quite a bit for geometry in general. Did you go through?
No, we didn't go over feedback. No.
We did yesterday.
We did feedback.
Just the screen.
Oh no, I just pulled up. That was a video feedback basically. There's actually a feedback operator which allows you to reference the previous frame from the last cook. So essentially, what he's doing is he's compositing the current frame over the last frame, and then darkening it just a little bit every single time, so that you get that sort of motion blur sort of effect.
Yeah.
He'll adjust the opacity slider on this level operator, and you can see that he can make it last really forever, or have it have the decay really, really fast.
Yeah. So it's a blend mode that basically goes to black.
The level top.
The level.
He just has the opacity set low.
What the feedback does is, as said, we close the feedback loop by referencing the node where we want to close the loop, and I just added a level to control the opacity of the old frame that gets composited over the current frame.
There's a lot of really interesting, pretty psychedelic things that can happen with the feedback top. Like if you drop in a find edges or a blur, it starts getting pretty weird.
Edge.
Yeah.
Cover your eyes.
You can start sculpting some really trippy stuff. Yeah, like that.
Yeah, it's great. This is a whole other
Oh yeah, HSVHS. Yeah, rainbow time.
Because now for every frame that it renders, it changes the hue by offsets it by 20. It's funny, sometimes you just build a really small, or I build a really small sub network, and I like what it's doing, whatever, and then I end up suddenly in compositing and keep compositing, and you end up in a totally different world suddenly that you didn't anticipate. I don't know. Displays is great with feedback as well.
Oh yeah, displays is super cool.
Let's see, with what though? Let's cache that.
Noise up? I don't know. Oh shit, cache. Crazy time.
I don't know. Let's see what happens if we.
You know what? I don't even know.
Beautiful.
Oh no.
Right, we got it. Huh.
Yeah, I don't even know what cache does.
Cache takes. You can cache an amount of pictures.
Oh right.
And output like you cache 32, and then you can output the third last
Yep.
frame or something like that. So this is, most of the tops are really most of the nodes in touch. When you try things out, when you learn it, it's about tweaking parameters and seeing what it does. The beauty is you're not going to break anything. Like if it crashes, but it's not going to be, you're not going to lose your computer.
Let's see how.
So the beauty is that you just keep working on your little networks and see what you can do with the displays, for example, by just tweaking these parameters very slightly.
Yeah. And then if you add some blur also to the displays, then it really becomes smoke.
Yeah.
Oh, okay. Let's see. Blur. Awesome. Blur. And what's beautiful
Cricket.
also when you go the wrong way around with these sample steps.
Oh what? Where's your? Oh, you negative samples?
Yeah, that works too.
Huh.
You can do.
Oh wow.
Oh well. There.
Just do a smaller number. Or like negative 10 or something.
Not a big effect here, but
You should throw a displace in there too. Displace it with noise, animated noise. Too much. No, keep going.
stop. Anyhow, that's a short overview of an audio. Maybe one other one.
Yeah.
This one is a geometry-based audio visualizer.
We've got a half hour left.
Okay.
Anything specific that we should do, or is there? Do you guys want us to show you anything specific?
I have a question.
Yeah.
Can you export object from what you are creating to use them in other third-party software, or is
Yes.
it standalone?
Yes, you can.
All the nodes have a save menu thing on them. So when you right-click onto any node, like this sub here, you would say, save geometry, and it saves it as a TOG and a BGO. Now, I'm not sure which one is the BGO, the one that is read in Houdini?
That's Houdini, yeah.
Yeah.
I think so.
Yeah.
So yeah, so TOG files are Touch Designer geometry files. So it's actually kind of interesting. He can save out a TOG file anywhere from any SOP, and then you can import that geometry back in using a file in SOP and some other network. But a BGEO file is only compatible with Houdini. Right, Greg? Are there converters? Are there any other programs that do BGEOs?
No.
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 So it's so as long as your program is Houdini, you can use the geometry.
Yeah. So.
Oh, sorry. I broke it.
Just slow.
It's just very slow. There we go. Okay.
That's something I've been asking for.
I can show this. There's one more here that's also a really simple one. Got the audio again.
Oh, that's cool. You've got a display center too.
So this one here is, again, an audio stream in, and now we convert it into a texture right away, into a chop. I mean, what it creates is these bars, which when you look at the at an audio stream, then all it is numbers over time. So you could interpret this very nicely as an XY, or it is an XY graph, which is basically one line of pixels, with every pixel having the value of the amplitude of the chop. So that's a straight conversion there. What it does, it creates one line. It's just one line, since it's one, well, how it is. What I did then I scaled it up, I changed the resolution, and then used something that I found in the palette, which is just a Cartesian to polar converter. So with this, it just creates this wheel by wrapping the texture circular around one point. And this I fed into a displace with a ramp as what will be displaced. And what can you do with the ramp? Well, change the period of the face. Oh, I have it here to hold. Let's put repeat in. Well, I mean, it's not pretty.
Change the periodicity.
Period, right? And
How it's holding. There you go.
Oh, well, anyhow, hold. So what comes out of this is just this displaced ramp here, and this is just to put it onto a 1920 by 1080 size canvas, and then I use the feedback to achieve this. I don't know what to call it, like this jelly thing.
Really dessert.
And again, by tweaking the parameters, or yeah, this. Oh right, yeah, I'm scaling it a little bit. Oops, sorry. So by scaling it a little bit, and pretty high opacity, but not too high on the level. The blur. This is an additive, and in the end just add an edge to it to give it this green glow, or you just leave it white, that's possible too. So that's another example where actually it's a direct conversion from audio to graphics that's a one-step conversion plus a feedback loop. That gets you that pretty quickly, and otherwise and since you see what you're doing, you kind of can play around with it. You're not stuck thinking, or I mean, that's not true. You don't have to think it through completely. You actually might end up somewhere completely different than you anticipated, but you might like it.